Do you want to know the mass of the Earth? Yes? Well, let's find out with the moon's orbital time, distance from the Earth, and a little bit of physics. To find the mass of the Earth, let's first address centripetal force. Centripetal force is the force that governs all circular motion, like a string and a ball. Pop quiz, which way does the force on the ball pull? This way. No. This way. Why did the direction of the force keep changing? Newton's law of inertia states that an object won't change its motional state unless acted on by an outside force, so the ball must have been acted on. But from what? It turns out that directing inwards on the ball is a force from the string, causing circular motion. This force is called the centripetal force. What are the components contributing to the centripetal force? Speed? Yes. String length? Yes. Mass? Yes. So mass, speed, and string length all directly determine the strength of the centripetal force in this equation. Anything in circular motion will always have a centripetal force acting on it. Turning cars, playground swings, and planetal orbits. We have the moon. Here's one force, and the Earth pulls on the moon to create centripetal force. But why is the Earth pulling on the moon? Because gravity. If gravity is a force pulling on the moon, and centripetal force is also a force pulling on the moon, that means gravity and centripetal force are essentially the same. So here's the equation for gravity. Now, gravity is equal to centripetal force. Cancel up some repeating variables, and we end up with this equation is all. If we find our orbital distance and solve for speed, we'll get 1.0 times 10 to the power 3 meters per second. Now let's go back to our equation and solve for mass. Amazing, right? So go out there and tell all your friends and family that you know how to find the mass of the Earth without lifting any more than a pen. Disclaimer.